You good?
Okay, you're streaming.
All right. Hi, everyone. Welcome. Thank you for coming. For the sake of the camera, this is the San Francisco PHP Meetup Group. Hopefully, you all know that as well. Big thanks tonight for our sponsor, Mashery. They're providing Jacob's time, facility, food, all that kind of stuff. So let's give them a round of applause. Also, big round of applause tonight for Engine Yard. They gave us that. We now have a new logo. Still doing a couple little tweaks to it, but that's basically what it's going to be. SF going into the PHP elephant. So they spent a lot of time on that. We're going to.
When are you going to make T-shirts out of the logo?
We are going to be making T-shirts and stickers and all sorts of fun stuff as soon as we get the color schemes and everything totally finalized. Hopefully, I think he said next week.
That's the sponsor for the T-shirts.
What's that?
That's the sponsor for the T-shirts.
Yes. So we will find sponsors for T-shirts, that kind of stuff. But that's coming along, so really exciting. Tonight we have Jacob Mather from here at Mashery. He's going to be doing an introduction to programming languages. So that should be really interesting. Coming up on July 28th, we have a combo SF MySQL and SF PHP meetup. It's going to be an MPP database using shard query. That's a really interesting thing where basically it's a PHP library that when you have a sharded database, it issues out the queries in parallel, brings it all back, stitches it together for you, and does a lot of it behind the scenes. So it makes it really easy to get to a lot of data when you have sharded databases, which is usually a huge pain in the arse. Missing any other sponsors? I think that's it. Lithium sponsors a little bit of my time to help with that. They didn't do much this month. JetBrains. We're going to be raffling off some IDE licenses. And with that, anybody here hiring? Just raise your hands. All right, so those of you that are looking to be hired, those are the people you want to talk to. Kind of switching it around to make it a little less embarrassing for those people that are looking for a job, because some people didn't like the fact they had to raise their hands. But there's lots of good connections here. Ask around if you're looking for a job or looking to hire someone. A lot of really good people at the group. And with that, we're going to turn it over to Jacob.
How you guys doing tonight? Good?
Yep.
Awesome. So this is going to be Introduction to Building a Programming Language, and I have a little bit of wandering stuff first, but we'll get there. So who am I? I'm Jacob Mather, software engineer at Mashery, co-organizer of San Francisco PHP. I call myself a community evangelist. I'm a really strong believer in the power of what you can get out of interacting with the community. I spent a long time just being a developer all on my own, building stuff, fine, whatever. Then I went to a conference. I went to Symphony Live out here, actually. And 6 months after that, I had relocated out here and started at Mashery. And it's been pretty much absolutely crazy ever since. The value of being involved in the community is really just, it's hard to even quantify. You go to conferences, you make connections to people, and all of a sudden, you know the people who wrote these tools that you use. You know the guy who wrote Guzzle. And so when you run into a problem with it, it's no longer quite as scary opening up that issue in GitHub or sending in a pull request, because you guys can joke back and forth with each other about something that happened at the conference. And you have those connections that you can go back to when you run into trouble and you run into things that you don't understand how to do. Community gives you those resources so that you know how quickly you can get unblocked when you get stuck on things. So really, thank you very much for coming out. It's a really good thing to just be here and be involved and talk to each other and meet people. If you have any interest in all the stuff I talk about, I blog at my website. I'm on Twitter here and there. Yeah, that's me. So really, I love to build things. I go a little bit crazy sometimes building things. I look for things that are just fun to build. Like, I have a project that I've been working on. I've taken the game of Mastermind. How many people know Mastermind? Okay, it's a pretty simple game. You get a couple different colored pegs, and somebody picks 4 of them and sets them up in a hidden spot where you can't tell what order they're in. And then you guess what order the pegs are in and what colors they are and all that fun stuff. And as you go through trial and error, they tell you, like, okay, you got one of these right, you got one of these right, and it's in the right spot. And it's just a kind of iterative process. It's a very small app. If we open up the PHP one and scroll down to the bottom, you'll see it's 91 lines in PHP, all said and done. It's a very small, simple solution. But then I've taken that and programmed it in 20 different languages. So that kind of happened because I went to a conference and started talking to some guys about Erlang, which really went crazy. It's a really interesting language, and just kind of got a little bit of a bee in my bonnet about languages and understanding, like, what sits underneath what we do every day. Because every day we go and we write code, but we don't really ever look under the hood very much. We don't really, I mean, we know these for loops, and we know assigning variables and all that stuff, but we don't know really what makes it work. And so as I started doing this, it started making me curious what made it work. Because as you end up writing these, you start to see that almost all of these look pretty much exactly the same. We have the C version. C has a little bit extra, got to do your includes, where we set our variables, and we do our introduction, generate a solution, do our user interaction. It's a really, really just sort of, there's a couple functions that everything uses, and everyone ends up having those functions. So here, we'll go through the PHP because that'll be clearest. Set up our basic variables, solution length, max number of guesses, characters we're going to use for right, wrong, and the guesses in the answer but not in the right spot. We have a function for saying our introduction, function to generate our random 4-letter solution. I went a little bit crazy with the PHP shorthand code there. We have code to get the guess from the user, which is the ask guess, where we actually get the console input. We have get guess, which validates that console input. Analyze tells us our solution. Game intro, get our solution, start our guesses, main body loop. But if we go and we look at the C, and there's more stuff because there's less already done for you in C. You know, you have to do a little bit more yoga to get the same sort of results. But essentially, we have our game intro, generate solution, ask guess, is valid guess, because checking if it was a valid guess was 10 times more complicated in C than it is in PHP, because C doesn't have all the nice things for working on strings. We get our guess, and analysis of the guess. It all has the same parts. Each programming language, especially when you talk about the C-based stuff, they all really look and feel the same sort of thing. And so that really sparked my interest in why people would build things that look so similar. What's the advantage? What's the purpose? And so then I went a little bit crazier and started looking at things like Erlang. Erlang is interesting because it's primarily a functional programming language. It has a few other weird things, but its syntax is very foreign. You're looking, this is a method definition. That's weird. But it's less weird when you start looking at other functional languages, because most functional languages like Erlang and Haskell and OCaml, they look like this. And this is just the style that's used. The other interesting thing is you learning other languages is you find out things that other languages have. You'll see this line. This line looks really kind of strange. What it is Erlang and a lot of functional languages have this thing called pattern matching, where you can actually take a variable and break it apart in a simple assign. It's like the list function in PHP. Have you ever used like list AB equals split string on something? It's like that, but it's like baked in. And so this line says, give me a chunk of random bytes, and we know it's going to be 12 bytes, and we'll assign them to these variables in 32-bit increments. And so then we end up with 3 variables, both holding, all 3 of them holding 4 bytes with just one line. And it's interesting because it lets you do pattern matching on functions as well. So if we call this function with the first argument of 0, this is what's always performed. But if it's not 0, then it runs the other part. So if we switch from Erlang to, say, Haskell, you'll see that the same sort of style persists. It's not quite the same syntax, but it's similar. Now if we go really crazy, and we'll switch to yet another type, because now we've seen C-based languages and we've seen functional languages, which tend to have the same sort of syntax stuff. And then, I guess technically, Ruby and Python are a little bit more distanced from the C-based stuff, but they follow that same sort of pattern. The one that I found was really interesting was this one. This is Clojure, which is Lisp-based. And an interesting thing about that is, aside from all of the parentheses, there are lots and lots of parentheses in this. The really interesting part is, in Clojure, the code is data. And so if you're in the REPL, you can actually have the REPL print out all of the source code for anything that you want, because all of the source code just still exists. And as you can see, it has the built-in functionality for documentation for the functions. It's already built in. You just go help and function, and it'll grab whatever the first string is that you define there. So now I ended up with all of these different languages and all of these different ideas, and so I had an idea of what was available out there. But if you're stuck with having to pick a language and having to use, one of the things I really miss when I'm doing PHP is the pattern matching. I think that's really cool. I think that would help do some things. And so I started wondering, what it takes to start building my own programming language. And so through that, I started building out a small implementation of PHP in JavaScript. So before we go there, let's talk a little bit about what it takes to actually build a programming language. Now, when you actually look at a programming language at the high level, and we're going to go with a script language, just because that's much simpler to explain than trying to go into compiled stuff, and especially if you're here for my little dab on talking about opcodes and stuff, not having that layer makes things a whole lot easier to explain. So we have the whole process where you feed the source code into a lecture, which turns the source code into a stream of tokens. The tokens are key pieces of the code. So if you have a language where white space matters, white space may end up being an explicit token. Function usually ends up being a token. If, true, false, things like that. Basically multi-character important things. These are generally what end up being like reserved words, like continue and break and all that stuff. Now, it breaks the source code into those and feeds those into a parser. The parser has what's called a grammar that says, given these tokens, I know how to take these small pieces of tokens and build them into logical pieces of code. I know that in PHP, when I see a $sign and some string of characters, that's a variable name. The grammar tells the parser what that sort of information is. And then it can tell you that these are the valid things you can do with a variable. It just goes through and describes basically every sort of possible combination of source code you can make. Every valid combination of source code. What the parser outputs is called a syntax tree. And so you literally have this like mind map, basically, of the flow of your program. Essentially all possibilities of what could execute will live in that syntax tree. And you feed that into the virtual machine, which runs a cyclical loop between the interpreter and the runtime to actually execute your code. So if we're looking at how we build a parser, because that's the first part, that's the base part, is we need to turn that source code into that syntax tree. Now, if you look at it from like the traditional C side, if you're building it in C because you want to be very performant, or you just don't like yourself, you might use Flex and Bison to build it. So we have this set up here, and there's kind of three different pieces. There's things that you've created, there's things other people have created, and there's things that have been generated. And I thought that was like a nice way to classify it. And so you'll see the four things that we provide in here are the source code, the token list, the grammar, and node objects, which we'll get into later. And you feed the token list into the Lexer builder, which is going to be Flex. And that combined with those together make a Lexer, which you can then feed the source code into, and you get a token stream. Then you take the grammar along with the node objects and push those together into Bison, and you have a parser. You can then feed your token stream through your parser, and you get your syntax tree that you can actually start to work on executing. For our purposes, we're going to use a tool called JSON. It's a JavaScript library that actually combines the Lexer and the parser together. And so all we have to do is write the grammar and token list for one tool instead of trying to detail a whole lot of complicated stuff. We do the node objects, feed that in, and we get the parser. We feed the source code into the parser, and we get our syntax tree. Much simpler, much easier, more straightforward. And the nice thing is pretty much every modern language is built like this. If you look under the hood of pretty much any modern language, you will see these same sort of patterns. You will be able to find a grammar. You will be able to find a token list. And you can use these to look at the language and actually understand even more than most people will see about it, because they only like go off what other tutorials do. The grammar is kind of the cheat sheet, because it shows you every possible thing that you can do in the language that's valid. So let's actually start to take a look at this. I'm going to go ahead and close this one. Because we don't need that one anymore. And so let's look at the tokens. we have a very small subset of PHP. We're not actually supporting a whole lot. Very first, we're going to ignore comments. Every language needs a way to comment stuff. So this list is basically, one side is the string to match on. These are basically regex patterns. And then after the string that you match on is what you want to do with that string. If you want to return something, if you want to do nothing. And so you see our comments here. We just ignore the comments, so nothing happens. New lines, we don't care about. Skip, general white space, we really don't care about. We care about single white space, a space, but that's why we use the plus, so we're ignoring multiples. Now we need our literals, so we need our number representation. I'm kind of being lax because JavaScript lets me be lax, and we're not worrying about the difference between a integer and a float in this setup. We're just not going to worry about it. It's all a number. It doesn't matter. Then we do our strings. We have two of them, one for single quotes, one for double quotes. If we were doing a more robust implementation, you would probably call one a literal string and one a dynamic string or an interpolated string or something like that, just to make it easier to know which string you'll need to do processing later to replace variables inside of. We have our true, false, and nulls. I'm only doing them lowercase. You could, do them in multiple cases. You could do it case insensitive. It's really all up to you. That's like our literal values. That's the things you will just type in and expect to be that when you're running the code. Now we have like our pieces of semantics. We have keywords. And so we'll do our open PHP tag, close PHP, public, private, protected, function, return, new, all that sort of stuff. The full PHP spec, much longer list. We don't need that. We're just doing a little bit of an implementation. So. Then we have our identifiers. Identifiers are going to be like the variable names, going to be numbers, or variable names, function names, that sort of thing. Any sort of stretch of strings that that is not enclosed in quotes is just going to be an identifier, because we're assuming that we want that whole thing and not just one letter at a time. Because anything we don't specify in here, we get one at a time. Now we have our operators for our multiple character operators. Equals, not equals, exactly equals, not exactly equals, and or access modifiers. Then we have our, if it's any character other than that, just pass that character along. That's what that means. I'm not exactly sure why it's called YY text. As far as I understand, basically that's convention. Because Bison did it, Jison does it. I don't know why Bison does it. Then we have our end of file. All very, just a little taste of PHP, just a little bit. Now, we have our tokens. So we know the fixed pieces that we're going to work against. So now let's take a look at the grammar. Now, grammar essentially has three sections. The first section is code to support the parser. And the only code that we actually need to support our parser is our node files that we've created, our node objects. We'll get into that. We'll go look at that next. It's a little rocky because you kind of have to know both of them to fully see everything. The next one is order and precedence of operations. So this controls how series of statements will collapse. This controls whether addition happens before multiplication or any of those sorts of things. As you go further down in the list, things are higher priority. So in this instance, it would always resolve a property reference before it would try and multiply or add or divide. Does that make sense? Okay. And this is just modeled after what it's supposed to be for JavaScript. Most of the languages really are all generally the same as far as order precedence of operators. They have some different specifics when you get into language-specific operators. But for the ones that you're used to dealing with, they're all pretty much going to be the same. So now we get to the actual meat of it. This line right here says the very most high-level thing that you are going to find that defines a program in PHP is this thing that we have labeled program. Now down here, program is the label. A program is made up of statements until we get to the end of the file, or it's made up of an open PHP tag and a program. Which means it's self-referential. Having this here is the exact same as if we did that. But it's just more succinct. They let you reference your own system so that you can more easily define things without having to get very unclear. So, a program is made up of statements. Statements are made up of a statement or multiple statements with a terminator and another statement. The code over here we'll go back and talk about real quick. So you have your statement and end of file, and we return the first argument of those. This one is wrong. This should never ever work. This is broken. This should be number 2. The $1, $2, those all refer to the actual order that piece is in. So you see down here, statement, this is the object that you return to when you build a grammar. You have to push the answer back to somewhere that the grammar is going to look to for an answer. And so when we have a statement, we will create a new block node. And a block node is just basically an array of statements. And so we will just pass it an array with a single statement in it. Because we will always hit a single statement before we hit multiple. You will always hit that first single instance. Now when we have 2, we already have our first one because we have statements. Statements is guaranteed to be a statement. So we push our third parameter into it, and then we return the whole thing. And if we have a statement and just a terminator, we just return the first piece. Down here, we define a terminator. If you wanted to also make new lines terminate, you could add a new line character there. Now, a statement is made up of an expression or a return. There's probably a little bit cleaner way to do this, but it's just getting the feel of things, getting the basic understanding of how to build this stuff. So now, an expression is either going to be a literal, right? We covered those. Those are our raw values that we just type directly in. Or it's going to be a variable, or it might be a call, or an operator, or a function, or any other expression that happens to be wrapped in parentheses. We don't necessarily need to do anything with any of these. We don't need to do anything special with them. We're just defining this expression thing. And so we're not defining anything to do. Now, we do it for the last one because we want to get rid of those parentheses. We don't really care about them. So we're just going to grab the middle part out and return that. Now here are literals. We return a number. If we get a number, we take the value for that number and put it into a number node and return that. String node, same sort of deal, except we have to cut off those the things with the curlies. The quotes, yes. We have to take those off before we put the value in, because we don't want to save those. True, false, and null, we just use true, false, and null nodes. So now we define a variable. A variable is $, and an identifier. And we'll create a new get variable node. That means we're using it. Now, if we have a $, and an identifier, and an equal sign, and an expression, that means we're assigning it. So if we see that, we will use a set variable node. And this is kind of a PHP uniqueness-ish, because other languages don't treat, some other languages anyway, don't treat assigning a variable as an expression that returns a value. PHP does. So you can do weird things like A equals B inside passing that to an argument, and it actually just works. Now a call is going to be just a function call. This is for a globally defined function. Our mini PHP implementation does not support objects. It does not support a lot of cool stuff. It supports registering functions. And a function call looks like that. It's got the name of the function, add your parentheses, and the arguments for the function. What are arguments? Those are right down here. An argument is an expression, or it's a set of arguments with another expression after a comma. Do you guys see how this is like just taking everything that you look at and just breaking it down into tiny little pieces and just describing like the most kind of inane details of the language. It's maybe more detail than you ever cared to get. Operators. We define operators as an expression with an infix operator operating on another expression. So this plus this, we return an add node that we pass the first and second expression into. Same for multiplication, subtraction, all that stuff. All works the same way. Basically, you just have to break it apart, put it into a specialized node, because later we're going to teach those nodes how to treat those values. Functions. We start with a keyword function. We give it a name, parentheses, parameters, open bracket, statements. I mean, that's what a function is. Sometimes we define access levels, but I didn't implement objects, so it's not super useful for our little mini language here. And in case we were wondering what an access indicator is, we have our public, private, and protected access. Parameters are defined as $name or a parameter and a $name with a comma in between. Same sort of pattern we've seen over and over. A little bit different because we're not assigning values, we're not treating them as variables, anything like that. We just need those identifiers. And then return is just a keyword implementation. This probably is not the best way to implement it, but this is what came to my head when I was going to do the code. So that is everything that our little mini implementation of PHP can do. That's it. But it's interesting once you get into it. So let's go look a little bit more. Now, we talked a bit about the nodes. So let's look at the nodes. The basic node definitions. We have a node block, we have a block node. This is any given block of code. Any chunk of code that's going to execute, we're going to put it in a block node. Block node needs a special method called push so that we can just add more in easily. You have number nodes. Oh, okay, question?
You have a syntax error. Capital B, capital L, block node, function, top one. No, to the right, there you go. You have capital L in that. Capital B, capital L, function, capital B, capital L, block node.
Huh.
Characters left. Should be lowercase.
It runs. I think it might be the font.
Okay.
Honestly. No, that's what this font is doing for a K.
No, the L.
L.
L is on the
Oh.
Nope.
That's a a little.
Apparently, it is decided it's going to show function names in a different font.
Okay.
Okay. I hadn't noticed that. I don't see fonts. I drove my designer friends crazy for years. I just don't see font differences. I would put together sites and they'd be like, why did you make it look like that? I just used whatever the default was.
Equivalent of tone deafness.
Right.
Font blindness.
So, block nodes without any syntax errors, actually. We have our number node, string node. These are our literals. They're very simple. They just hold a value. Value nodes, we keep this pattern just so it's stupid simple for accessing them. If we built it in another language, we might do something a little bit more complicated, but JavaScript lets us be lazy. I like being lazy sometimes. We have our true, false, and null. Very simple. They don't really do anything because they don't have any values. The whole point is that they don't. So, now we get to the more interesting ones. Interaction stuff. Get variable node. We need to know the name of the variable to return when we eventually execute this. Maybe. So, we store the name of the variable. Set variable. We need to know the name to store, and we need to know what we need to store. So, we accept the name, which we expect to just be a string, and we accept the node, the value node, which this is going to be like a piece of the syntax tree. This isn't going to be 3. This will be a number node with an internal value of 3. We have a call node, which has our names and our argument nodes. Function node, same sort of thing. Optional access value, name, parameters, and the body node. The body node is going to be, again, a block node that is just a chunk of arbitrary code to execute. We have a return node, add node, subtract, multiply. These are all really kind of the same sort of thing. You see the same sort of pattern. And that's the nodes. That's the discrete chunks that we are turning our PHP code into. And this is like the basis of the syntax tree. When, after the parser is done, you have basically a very large multi-dimensional array full of these objects that describes the entirety of your program.
Let's say we're defining something like I just blanked on the name of it, but like a number exclamation point recursive addition.
Oh, factorial.
Factorial, thank you. So would you build a loop in this part?
I would do probably a factorial node. If we were
would that contain a loop like based on n?
Not in this part. This part just describes holding the values.
Okay.
If you wanted factorial to be a native part of the language, you'd set it up in here, right? But not if you're, otherwise the function, you just let it delegate to this, right?
Right. Otherwise, if you were building factorial into the language, then you would create a token for it of some sort, maybe. Or if you're just going to use the exclamation point to indicate that, you probably wouldn't use a token. But you'd definitely make a grammar entry for it. You would use like number exclamation point. And that would just describe that when it sees that combination, it knows it's a factorial. You'd want to make sure that you add it to the order of precedence list and probably make it pretty high. Just so PHP knew that that needed to be executed first before it did anything else.
Yeah.
But we could actually do that at the end. I'm totally this is all code. This is all works. I don't know how that one piece of code I had that was wrong works, but it works. I'm more than happy. We can go through add like if add for add factorial. That's the best way to learn how to do this stuff is actually to see it like grow. Mm-hmm. So these are all the pieces for the core system. These pieces together, we can now turn code into a syntax tree that can actually start to begin to be executed. So now we need to look at the rest of the system. And the rest of the system is the interpreter and the runtime. The interpreter is the easiest one, or the harder one, sorry. The runtime is a little bit thinner and simpler, and so we'll look at that one first. The first things first, we define the concept of a PHP value. We need to separate, for our own sanity, the difference between a JavaScript value and a PHP value, or we will go insane. The template that I used, the base template that I used for this was by a guy named Mark. I'm not going to butcher his last name. I couldn't even begin to remember how to say it. He's French Canadian, so I'm just not going to do it. He built a small implementation of JavaScript in JavaScript, and actually keeping track of which language you were writing code for hurt my head.
Yo, dog, I heard like JavaScript through JavaScript.
Right, and so that's kind of why I picked the JavaScript and PHP, because they're visually kind of very distinct, and so we could maybe see a little bit more of a difference when we're in the muck, as we're about to be fairly quickly here. So we have our PHP value, and our PHP, in order to do anything of any sort of value, really in any language, you need a scope. You need somewhere to start storing data. So we define our scope. Our scope will have locals. Our scope will have a parent scope because I wanted to have it there. PHP doesn't really have parent scope so much. New functions have their own excluded scope, and we have the closure stuff now. But even that's like weird because it's not like a real closure. It's like a closed scope function that you kind of shove your data into. So we have our scope, and the scope is where we get to store stuff. And then we implement a couple helper functions. Has local, only really super useful if we're doing the inheritance scope stuff. Now, has is helpful because that gives us a quick access way to say whether or not a variable has been defined or not. And get will return the node that we have stored into that variable. Not the value, the node that stores the value that we put into that variable. Set puts that node into the variable and saves it. You can see it, we check and see if we have it locally. If we have it locally, we return it. Otherwise, you know, the code is all really generally kind of straightforward, I think. Do you guys have the sense of that looking at it? Does it like kind of just sort of make sense? Because it's little pieces of code. The totality of it's kind of a nightmare. But each little line of code is fairly simple to follow. You know, so if we're setting a variable, we check if this is the root scope, or if we've already assigned this variable locally, or if there's none, if this variable has never been assigned, then we assign it to ourselves. We take that scope because we're the parent scope, we have it. Otherwise, we sign it up the line because somebody else actually owns it. That's it for the scope implementation. That's all you need to actually like track variables and values and stuff. So now we have our implementation of a function. We have a separate PHP function system because the runtime needs its own way to describe what happens when you make a function call. So when we make a PHP function, we have the name, the parameter, and the bodies, just like we saw when we built the node. And it's just a different context of a way to deal with it. So now that probably looks familiar. All right? Anybody recognize that? Now, so I follow the same sort of pattern because this is essentially what PHP does as well. And that's why they picked that for the magic function name, because that's just what they use. And so the system already is set up to look for it. So when we want to call a function, we create a new scope. Then we iterate over our parameters and assign those parameters into our scope. And then we evaluate the body of the function, passing it the scope that we just created. It's kind of a external view, and it's a little bit weird at first. But the way you actually execute the nodes is you give them what they need to run, and they operate on it and return it, or not. So it just lets you, it gives you more control over what's happening, because the runtime is what actually knows everything is going on. We deal with our primitives. So we're basically defining the global values of true, false, and null now. So we wrap them in PHP values because that's how any of the PHP code will actually return them. And so if we want to equate if they're equal, it helps us if we're already set up. Now we need our actual scopes to exist. So we define our root scope, which is going to be the variable scope that exists when you just do your open bracket question mark PHP. When you start your PHP, this is the scope that exists. We also create a separate scope that we're going to store functions in. I don't know particularly if this is exactly the correct way to do it, but PHP saves its functions separately from its local variable scope. They're defined globally. So it makes sense to just keep it to separate store. And we have this handy little tool that's built for tracking things like that. So we just reused it. And now we see the one built-in function that I've created for our very small version of PHP. We have print. Print we will assign to the function scope, and it's going to be a PHP function named print. They will accept one parameter. We will name that parameter content. And when the eval function is executed, because remember that we're talking kind of meta programming at this point, and so nothing is going to execute the function directly in our code. We're going to execute the eval function passing in a scope to execute. So when we evaluate this function, what we want to do is retrieve our variable from the scope, and we're going to strip out, or we're going to replace any new lines with actual new lines. I'm not exactly sure what happens inside of JSON, but new lines get escaped. Something to keep in mind. Surprised me. Then once we have that, we write it to our standard out. Simple function. Now we know the basics of what's available and what we can do. Let's take a look at the interpreter code. The interpreter code is what actually executes your software. This is where the sausage is made. This is where all of this stuff comes together. So we have our block node, and we're going to add the eval function to it. The eval function takes scope. And what we're going to do is for each of the nodes that we've given this block node, we're going to execute evaluate on it and pass in the same scope. And in the event that we receive an exception, if that exception is a return, we'll return the value that we received. Otherwise, we will just throw that exception again, because that's not something we know how to deal with. In the event we don't receive an exception and we don't have any other problems come up, we'll return null. So something's returned, and I believe that's actually what PHP does, but I'm not 100% sure. Down here we have our very small return node implementation. I left this here because this is used specifically for the block node execution. We don't use this for anything else. I'm sure if the language was built out more, if we got case statements or for each, there would be better ways to refactor this so that more things could use it. But for this particular instance, I just stuck it here right by the code that uses it because that makes it most easily understandable. So now we'll go and look at our literals. When we have a true node and we run evaluate on it, it just returns the runtime's copy of true. That's all it does. Same for false, same for null. Always the same values, so they're always equal, they're always exactly equal. It's all the same thing. String nodes, what we do is we take the value that has been passed into the string node, because these are literals, right? We've encoded the exact value we want in the source code. So there's nothing to evaluate there. We already know what that value is. And so we just take that value and stuff it into a PHP value object and send it back. So the PHP is ready to deal with it. Same for a number node because it's a literal. We know what that value is. For a get variable node, we look at our scope and we return the value that we get from the scope with the name defined. Same sort of deal for set. We run scope set, we pass the name. Only here you see it's a little bit different. Here, before we set the value, we evaluate what that variable is going to be. We actually run and process that variable so that we know what that value is going to be when you set it. This is interesting because this line right here will change depending on the programming language you're talking about. Many languages, especially the C-based imperative style languages, will execute as quickly as possible. As soon as possible, it will try and resolve basically the uncertainty of what that value is. So if you type, trim string, as soon as it gets there, it will go, okay, I'm going to trim the string now, and then stuff it in the variable so it's just ready to go. Other languages, like Haskell, sit on things forever. Haskell tries its best to never, ever do anything. And so it's really interesting because while PHP, in PHP 5, I believe, we got yield, right? Which lets us build generators, which is really interesting for PHP because we haven't been able to do that. We haven't been able to build a function that basically has multiple return values out of the same function in that sort of manner. But that same sort of thing just happens natively in Haskell by just returning a value. Everything in Haskell can be a generator because nothing is actually executed until the value is really required. So you can have this giant long line of code and none of it will actually run until you try and print it to the screen.
I think those are called thunks, aren't they?
I'm sorry?
Thunk? Isn't that what that's called in Haskell? I've been reading on that a little bit.
No, I'm sorry. I still having trouble hearing you.
Thunk?
Thunk?
Thunk. I think that's what that's called, like that delayed, deferred.
Yeah, that's right.
Funny name.
Yes, I believe you're right. I believe the term for it is thunk. I've also heard that in relation to, I want to say Erlang, but I don't think that's right. Thunk is the word, I believe.
I think it's common for functional languages.
Mm-hmm. And it's basically just controlling the context of when things are actually resolved. So that's interesting because you kind of define a lot about the language in this one line because that changes a lot of the behavior mechanics. So now we'll define our function node. And when we have a function node, what we're going to do is we're going to create a new PHP runtime function with the name and parameters and body node. Then we'll take our function scope and set this into it so it's ready to use. Call node, we grab the function we need, and then we put our arguments into the scope that's required and execute. And then we're down to our operators. These all look fairly similar, I'm sure. We create a new PHP value. We evaluate each value that we've been passed, and we do the simple operation of whatever's requested. So all of this code, this little bit of code, together, that's all you need to start building a programming language. Now,
So,
sure.
I don't understand the distinction between the runtime and the interpreter. Why are we dividing the code this way?
Basically, the thought behind the division is the runtime is kind of the static pieces that you need to put all the glue together. That's where your definitive definition of true and false and null come from. That's where your special like meta values come from. It gives you like the definition place like this. Like the runtime is kind of like the nodes file for the execution of things, where we had the nodes to store just the general metadata about the tokens and source code. We have the runtime to provide support libraries for the actual execution of the code. But without the runtime, you don't get the scope and the ways to track variables. And so the interpretation executes the code. The runtime is where it lives. Does that make a little bit more sense about how it's broken down?
A little bit. I think you keep going.
It's like a back and forth.
Yeah.
So I think the best thing to do at this point is kind of show a little bit what it can do. It can't do a whole lot, but it can do a little bit. So we have our this has a test framework with it a little bit. And so we have our hello world example, some basic math, a couple strings, just testing stuff, playing around. We can also test each individual piece. So we can test that the lexer converts source code into the correct parts. If we pass in quotation mark hi, quotation mark, it returns us a tag with string in our value and the end of file. If we pass in true, it returns us a true node. If we pass in this weird stuff here, it returns the exact same weird stuff we would expect to get. And you do the same thing for the parser. We can say, if you parse the value 1, we expect to receive a block node that contains a number node. If we parse the statement 1 semicolon 2, we expect to receive a block node with 2 number nodes, one containing 1, one containing 2. Maybe next time I do this talk, I should start with this file. I think this kind of shows a little bit more, yeah? So now let's do a variable assignment, right? A equals 1. When we parse this, we expect it to return a block node that has a set variable node, which contains A, and a number node which has the value 1. So now if we go from there to the runtime, we can test pieces of the runtime, that it creates the scopes correctly, that functions operate correctly, that they're executed as we expect. We can specifically unit test our interpretation code, making sure that it behaves as we expect. We can tie this all together. You see we have our nice Mocha output here. The interpreter returns and all that fun stuff. And the lexer's doing its job, parser's good, runtime's good. And we even have sample files that we run, and we store both the... We actually don't store anything. If we look over here, our compare outputs file, this is the test that we use for our samples. We execute our node version of PHP and store that output. Then we execute the exact same file through PHP and store that output. If they're the same, it passes. I think that's a fairly decent test. Now, this is it. This is like the beginning of a programming language. We're going to change this. Hello, SFPHP. Now we'll do node, PHP.js, hello, SFPHP. So, are there any questions at this point? Any thoughts?
So after you worked on the grammar for a little bit, where you've got some new grammar that you're trying to support, right? You might want a way to visualize what the process tree is actually produced by. How do you do that? Like, how do you expect it's going out?
A lot of that is actually why the unit tests for the parser and the lexer exist, because you can use those, because you can start with, this is what it's supposed to look like after it processes. And this is actually where like test-driven design really kind of kicks in, because a lot of this stuff you actually know more specifically what you want about the results than you know about how you're going to get there. And so, at least I found through working with this that writing the test first for the feature that I wanted to add actually worked a lot better.
What are your thoughts on the object-oriented development of a language?
I'm sorry, one more time? A little louder?
What are your thoughts on the object-oriented development of a language?
I hadn't actually broken into the object side of it, but it doesn't look like it's going to be a lot more complicated to add object-oriented sort of stuff, but that's a very, very deep rabbit hole. Because once you start adding objects, you start worrying about tracking memory usage and that sort of stuff. And it's a very, very deep rabbit hole to get into, which is why I kind of left this without the, I don't know if I'm ready to get into that sort of complex detail with this stuff yet. I'm still just kind of like sticking my toes in the water.
If you're going to add statements to do conditional branching, like if, or can you outline where those would go in this? Where would you add those?
Well, let's do that. Let's add if. I think that makes a nice first start. So where we start is the lexer, because the lexer is the part that takes our source code and turns it into tokens. So we'll start, and we'll just add it to the bottom here. It handles if statements. We will say assert deep equals.
No S.
Oh, yep. Assert deep equal. If. What are we going to get with this? If. That works. Then we will need. I'm trying to think. I think actually I'm just going to skip this part because I don't want to get into that much detail and have you guys watch me writing that much of a unit test. I'd rather you guys just watch me write the code because that's the more interesting part.
Do you have conditionals defined within your grammar?
I'm sorry?
Do you have conditional statements defined within your grammar?
No, not yet. So we start with tokens because we need one token. We need our if. So we'll make this a new keyword, and we'll say if, and return if. We're not going to support else yet. We will just support if, because that makes it more fun. So now, there's nothing really like if that exists yet. So we get to create a separate one, and we'll say if. And an if will look like if, in an open parenthesis, and an expression, and a closed parenthesis, and an open bracket, and what is this going to be? Statements. Statements, and a closed bracket. And we will say that when we receive this, we will create a new nodes.if node, and we want to pass the expression, which is 1, 2, 3, the third one, and 4, 5, 6 is the statement. 1, 2, 3, 4, 5. Okay, 3 and 6. So we'll pass the evaluation expression that we want to if on, and the code we want to execute if that expression resolves to true. Trying to see if there's a more. Oh, there we go. I can close that. So that's our whole definition for an if.
Do you need a semicolon after that?
Sorry?
Do you need a semicolon after that?
Nope. Not in a grammar file. I don't know if that's just because it's JSON and
Well, you
it's.
have semicolons after breaking apart the elements, or is that just separating?
No, on like line 114.
Just above if and just above return. And
Oh, yes. Okay, thank you.
It's going to be your linter in the back here.
Yeah, also something to keep in mind when you screw up your tokens or your grammar file, JSON isn't the nicest like debug output. It's fairly ugly. So let's do a sanity check. Let's see if we've broken anything thus far. Make test. Everything still runs. We haven't broken anything yet. So now we have our grammar for it. Now we can conceptually maybe make an if. So now we will. I'm sorry?
Should something include if?
I'm sorry?
It should be included in something so that it can be included in the program.
It needs to be what? I'm sorry.
I think statements have one more alternative of if. In the definition of statements.
Right. The statements has a. Oh, yes, you're right. Because we need to actually tell it that. Because in PHP, if statements don't return anything. So they're not an expression. And so they're a statement. And so up in statement, we need to tell it that if is a valid statement to add. Thank you. I would have been very confused about why it wasn't working. So now we have our fully correct grammar. Let's go over here, and we will say exports if node equals function if node. What is it going to be? It's going to be expression block and body. And we'll just do this expression equals expression block, this body equals body. And there's our if node. A simple value holding device. And because we're not actually introducing anything new value-wise, all we have left to do now is write the interpreting code for it. So we'll hop over our interpreter, and we will say, we'll add it up here. We'll say nodes dot if node dot prototype dot eval function scope. Let's see, and then we will say if. Now see, this is why I went for two very different languages, because we're implementing if by using if. And if we were using, like, if we were building JavaScript in JavaScript, this would be much worse trying to wrap your head around. So we'll say if
There is no script.
this dot expression, right? That's what we called it?
Yeah.
Yep. Cool. If this dot expression dot eval scope equals runtime dot true, return, we don't return because it's an if statement and it's not that. Then we do this dot body dot eval scope. I think that's right. I think that looks like it's doing what we want. There's one simple way to tell. We go to samples and we will say if.php.
Do you really use strict type
Hmm?
Strictly true. Strictly equals runtime.
Oh, strict would actually be fine because runtime.true, it's always going to be the same object even. True is just true. It's always true. Anytime we have true, it's always just true. PHP does more fuzziness with what variables actually are. We're not implementing that fuzziness. We'll get a little bit of it because we're in JavaScript, and JavaScript is a little bit loosey-goosey as well. But so we'll do a test here. If 1 equals 1, print this is working.
Now, do me a favor. Put in another percent just below that.
Okay.
And instead of saying if 1 equals 1, because you're using expressions, use 1 plus 1. And then print 1 plus 1. And now print out stating whether or not that was working.
This should probably fail. Or rather, not execute, because this won't be exactly equal to runtime true.
Right.
Print, I shouldn't see this, even though that's not PHP.
Well, actually,
Well, PHP interpreter may actually interpret that as true, or, well,
PHP would use its PHP value internal
Coercion.
to compare them, and they would.
it's 0 or 1. It's based on C language.
Yeah.
And value is 0 is
Well, 0 is also going to fail because it's not runtime true,
Right.
and so we're not doing any of that stuff. So let's go PHP samples if. So this test is actually going to fail because this code works like this in PHP.
right,
So now,
1 plus 1 coerces to true. Doesn't
Right.
it? Yeah, in PHP.
right, but our sample version,
Right.
make test,
Fork.
it failed. There's a surprise because it doesn't know what to do with that. Because apparently we have not defined double equals as valid in an expression. Yay! let's do that real quick. So we go to our grammar, expressions, operators, operator. We need more operators.
Later on down the line, you probably want to create a category called comparisons or comparators.
Right. You know, you build this out more and you will end up with a lot more supporting code. And so we'll say this is an equals node. See how quickly the rabbit hole expands. Back to here. Exports equal node equals function node expression.
You want to be consistent with equals and equal.
Oh, yep. And I forgot to put a 2 on that one. So this and now we have our equals node, interpreter, nodes, equals node, prototype, dot eval equals function, scope, return. Let's see. So now we need to do equals this dot expression 1 dot eval scope. So we get our 2 values and we resolve those values to figure out what they are. And then equals will just return value 1 equals value 2.
You don't need to return the runtime true?
Nope. The scope is a living object. We just operate it on it. We just operate on it directly, so we don't have to return it. Oh, wait. That's right. We can't do that because that would return a JavaScript true to our PHP code. So we have to say if value 1 equals value 2, return runtime true. Else, something our language can't do, return runtime false.
Typo, background.
Yep. Let's see. That looks like enough. Let's go back to our test. Okay. Okay, so my definitions of PHP aren't fully. Oh, okay. I'm not entirely sure what's going on there. This is what's fun because you end up in these mysteries. It doesn't understand. So right now it's seeing it like this, and it doesn't understand what that means.
Collapsing on the white space.
Oh, you know why? Because our grammar is looking for a statement, right? And so we catch the if for a statement, and then statements are separated by terminators. We don't have a terminator on our statement. So maybe what we need.
Is an if block really a statement in the same sense? Because it
So,
doesn't require a
so
terminator.
for shortness of this example, you might want to just put a semicolon after it.
Yeah, let's just do that. Let's do that. Let's That may make regular PHP not happy though.
Yeah.
Let's see if we've broken real PHP. Hold on. There we go. Nope, real PHP is fine with it. So, it fails because it doesn't see it. They're different. It doesn't like it. But apparently,
Because of the 1 plus 1.
let's do node php.js samples if. Let's see what it actually does. It does nothing. That's helpful. So why does it do nothing? Let's investigate. Let's do a little bit of crack debugging. So we look at our if node. And let's just do this. Let's go up here. I'm going to do console.log.
That's why we should have done the TDD style.
Hmm?
That's why we should have done TDD.
Well, yeah, if we'd done it TDD, then we'd have a bit more. Oh, that's interesting. It doesn't think 1 is equal to 1. Everybody sees that, right?
Yeah.
The very first test is if 1 equals 1. Its answer is no. So apparently, we need to take a peek inside the equals node and find out what's going on here.
I have a sneaky suspicion that it's looking at the string 1 versus the value 1.
Perhaps. Let's see. That's too much output for me to deal with in the same way. Let's look here. Stop looking here. Because I've had instances where I was looking at the wrong thing the entire time. So, this is curious.
Well, the first one is for the 1 equals 1, and the second one is parsing out for the 1 plus 1.
Right.
The 1 equals 1 value false, and then the 1 plus 1 value 2.
Well, no, because
Because it's being that where you just put it as being called twice in the whole.
Oh yeah, right. We have 3 of those, don't we?
Hello?
No, we just have the 2.
Right. Go back to the other file. Go back to the Lexer, whichever one we're just looking at, or the interpreter. There we go. Because the equals node. Oh wait, no. It should only be called once.
Yeah. Because we get the 2.
Correct. It is being called 3 times. It is being called for the first if statement once. Then it's being called twice because of the 2 value 1s being added together, which is why you're getting the value 2.
Yep.
It's calling an expression.
So, why does it think that these aren't?
Can you give me...
Oh!
Value 1 and value 2 aren't PHP
Aha.
values.
There we go.
What if that does it? There we go. That's the true. Metaprogramming. Yay!
The expression 1 and expression 2 eval were returning the objects that were wrapping values. Is that what it was?
There. Now it's working. And so now if we run our test again, we get what I was expecting to see, because it didn't have any output before, but now it does. So if we go back here and we open up our sample again and we remove the incompatible one, actually we'll
Run it out.
we'll do 1 equals 2. All right, we'll do something that's supposed to fail. Make test, everything runs. And so now you can kind of really get a feel for how far down the rabbit hole you go very quickly. Doing something simple as implementing if. Any more questions?
We were going to
Sure.
try factorial.
I'm sorry?
Were we going to try factorial?
We can possibly. Let's make sure there's nobody else that
Sure.
has.
I'm just wondering if you have any real-world use cases in mind for this.
I actually do. One of the things that we have that I talk about quite a bit at conferences and stuff is we have this system we call local dev, which is our local development environment. Funny enough, when you have lots of people running code that is supposed to do the same thing all the time, you tend to find that that code just doesn't. Especially when it involves virtual machines and having to do build processes and stuff like that. And errors that happen during bringing systems up 1 in 100 times tend to happen once or twice a day. And systems get in very strange states. We've had a bit of a problem teaching people how to go about debugging these things well. Because really it's like full stack knowledge that you're trying to convey to people that probably don't have it. Trying to teach them, SSH into servers and teach them about Apache and the finer inner workings of how PHP communicates to the database and all the nuanced details of how our entire architecture works. There's a lot of information to just kind of have in your head. And so the first thing that actually came to mind to put this to good use was going to be coming up with a language to describe both the checks to do on the environment to make sure that it's in a good state and the steps to perform if those checks fail. I could do this in regular code, but then people we have that aren't coders couldn't look at it and have a very clear picture of what exactly was happening through the troubleshooting steps. It removes the cruft of the code from something that can then become documentation and a tool. It's like it's like Behat. Have you played with Behat at all with functional tests? Behat using Gherkin. It's a cool setup. It lets you describe in words what you want your test to do, and then behind the scenes you write programming code that converts those words to actions. And so it makes it very clear what you're testing. It makes your intentions very straightforward. You can pull someone in off the street if you have to, if you need more manpower to work on things and say, what is this test supposed to do? And with a Behat test in Gherkin, you should go, well, this test has these 5 steps, and I can just sit at the computer and go click, 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 click. It tells me what to do. It tells you exactly how to test something. The same sort of theory I have behind building a tool to debug environments and bring them back to a good state is we can both use the tool to A, fix the environments, and B, teach people who don't have the full stack knowledge they need to actually understand how the entire system works. Commonly, these are called domain-specific languages, DSLs. I mean, if you look up, there's tons and tons of use cases for various aspects of these. Whether or not those use cases are particularly needed is another thing entirely, but it's a good tool to have in your toolkit in case the problem arises. Don't go out thinking that every problem needs a domain-specific language. But now, when you encounter a problem that you think might be best solved by one, you know the tools to begin looking at to figure out if this is something you can tackle or not. I thought I saw a hand go up over here, maybe? No?
Why have you chosen JavaScript for building language? Is there a reason for that?
I particularly chose JavaScript and PHP for the target audience. I figured if nothing else, you guys would probably know JavaScript on top of PHP. They kind of just go together. If you were worried about performance, you would not use JavaScript. But especially for demonstration purposes, or even if you don't have a performance requirement and want to lower the barrier for the amount of knowledge needed to start working on it, it's not a bad option. JSON's a great tool for doing this.
Piggybacking on real world examples, you can't imagine, since I think it's ludicrous, but having a built-in encryption. So instead of having literals being whatever it is, but you have a cipher, so shifting like a literal. And so your actual file is encrypted, but then once it's parsed
Yeah.
decrypts.
That could
It's
definitely be a useful scenario, but realistically, you'd probably just want to write a shell script that
Yeah.
decrypts it and executes it, than replacing the entire language.
Okay.
Generally, if you could make it a smaller, discrete task, you want to do that over, especially replacing an entire language, because
Yeah.
we've seen how
Okay.
perilous even simple things can
Validation
be.
just helps me understand like that. Okay, I can understand a little bit of the possibilities.
Basically, the way I look at it, and kind of like the wider view, is all languages are abstractions of problems from languages that came before it. Assembler solved the problem of having to code in hex. C solved the problem of having to code in assembler. The assembler is kind of hefty. It gave us variables. It gave us not managing stacks and frames. And we got bored with only having those abstractions, so we made C++, which gave us objects and maybe a little bit more robustly defined memory management. We got bored with managing memory, so we made Java and PHP and C and all these other languages on top of it. And that's kind of where the scripting languages start getting born, because you care a little bit less about performance and you care more about just flexibility and things that you can do. You'll find that pretty much every language has like a target audience. They have a target purpose. If you look, Google intends Go to be like their replacement for C. Apple intends Swift to eventually replace Objective-C, I assume. Maybe even more if they can get it off of only the OS X iOS platform. It's a very nice first run language. I don't know if anybody's played with it yet or not. Yeah. I have a sample up in my mastermind repository because I saw it come out and I just couldn't help myself. A little rough around the edges, but it'll get there, I bet. Every language is built for a different purpose and different helpers. Like Erlang was built to run network switches. So its primary purpose is to be able to parallelize tasks and be super, super reliable. And so it ran network switches, it can do live code refreshing, it has built-in methods for distributing code so that they could have multiple instances running on a switch so that each port could maybe have its own communication dedicated process. Ericsson used Erlang for their phones in the 80s, and they were able to do over-the-air updates without the phone breaking. Java has all of its multitude of use cases. One of the first ones that I didn't know about was being backwards and forwards compatible. And I was talking with these guys at a conference, and they're like, yeah, you could take code like many generations down the Java line and run it on a really old compiler, really old VM, and it would work. It wouldn't necessarily be the fastest thing you'd ever seen, but it would actually work. That's kind of crazy. And so every programming language encapsulates a problem and deals with it in their own kind of domain-specific way. And I find that context kind of helps when looking at languages. And that's why some languages are more appropriate for some things than others. Any other?
So I actually came in here thinking one use case, but this kind of went down a different route of creating like a domain-specific language for embedding into HTML pages in terms of attributes to sort of run like arbitrary JavaScript code without having to write literal JavaScript code in attributes, for example, like data attributes. So I'm kind of curious if you have any ideas on how you would go about implementing that, because obviously you have to run front ends in the browser. If there's any tools for putting together that kind of thing that you came across.
Basically, this is JavaScript, so it compiles in JavaScript. You could load this up and have it run through the browser. You could build your meta HTML language here, and all you'd tack on is like an auto execution on load, and you could build your HTML however you wanted and include the file, and as soon as the file loads up, it'll look at the page and do its rendering evaluation magic. Now, granted, your page would look really weird until it loaded and ran.
Well, no, I'm talking. Trying to think of an example, like being able to declaratively define a click handler on an element.
Ah.
That kind of thing. Not like
Okay.
pre-processing.
I don't know really enough because I mean in theory it's JavaScript. You can
Right.
probably figure out a way to make it happen. I don't know if there's like an elegant way to make that sort of thing happen.
Right. I mean, it's mainly you just need to have it'd just be a matter of having the lexer, I guess, to break it apart into different tokens that you need.
Yeah.
So I guess in that case you just need to run through a lexer and then interpret it from there.
Yeah, actually, and if you wanted to see like a small scale lexer implementation, I have a repository in my GitHub called Tag Parser. It's written in PHP, and it's not using any of like the super fancy JSON stuff. So it's probably really ugly code, but I needed a way for non-tech people to quickly search a tag database. And so I created this very, very simple grammar that had parentheses and addition signs and like a couple special operators. And they could do all sorts of crazy magic with just adding and subtracting tags. And that would turn into the search language. Technically, it's a very tiny domain-specific language.
Have you worked with higher languages beyond C-type languages?
I'm sorry, have I worked with?
Fourth and fifth generation languages?
Like?
Yeah. Oh, SQL and OSQL and...
No, I mean, I do some SQL stuff with, general database work and everything, but I haven't really dug in. It's really only like the baseline. This is what I need to get my records. This is what I need to insert. Nothing super fancy.
Okay, so you haven't tried building a fourth generation language through this process?
No.
Okay.
Any other questions?
What is the fifth generation
Fifth generation language is as close to English or natural language as you can get. So if we're speaking English, that would be a fifth generation language.
So the question was, what is fifth generation language? And I don't actually know like the generations of languages. I hadn't actually realized that people would classify them in that manner until now. But fifth generation language is what you're listening to right now.
Sounds kind of like what Gherkin would be classified as. Sounds kind of like what Gherkin would be classified as.
It kind of, yeah, maybe. Sorry.
I was going to ask what's in the php.js file that you run through Node.
Let's take a look. I'm surprised I didn't show you. It's like the last piece of the secret sauce.
We kind of went down the rabbit hole of implementing other stuff.
Yes, we did. So here's the entirety of it. Load our parser, interpreter, runtime, and the file system helper. We get the file that we want to execute, and we read it into a variable. We parse it into the node tree, the syntax tree, and that could be your whole. That's like could be where you do your debugging. If you want to visualize the syntax tree, right here you would just console log node, and you would just see the entire program.
You should show us.
Sure.
If it's that easy.
We'll find out. Node php.js, and we will just do samples if. So when we evaluate that file, we get an object that has a node. So it loses its object content. So you don't know what kind of class it is, but yay, JavaScript. So it has an expression, which is also an object, but apparently it doesn't want to tell us what it is. And the body is an object. Cool. And it just has two of those. And then the last part, you run evaluate on the node with the root scope, and that executes your entire program. It's interesting how you build all these little tiny pieces that don't actually do a whole lot, And then you can put them together using little tiny pieces that don't actually do a whole lot, but you make this very complex piece of thick machinery.
Yes.
Any other questions?
What
Two.
if you go the other way around? If you want a PHP implemented
I don't know what PHP has as far as building lexers and parsers. I think it has some stuff, but I don't know if it has anything quite as robust as JSON. I considered that. I considered doing the PHP implementing JavaScript or something of that nature, but I knew JSON, and I knew that would work, and so I went this side instead. Anything else? Awesome. Thank you very much. Woo! I also wanted to add, this is kind of like my birthday